These are your 8-1A notes, polynomials. A lot of terminology in this section, a lot of just understanding what a monomial is, and then we'll work with them on the next day. We'll learn how to add and subtract these things. I'm not going to read a lot of this to you, so you can go ahead and pause if you need to write these things down. A polynomial, sum or difference of monomials, or just simply a monomial. If you remember from before, a monomial is multiplication of numbers and variables together. So we just worked with all the monomials in Chapter 7. Now we're going to take more than one monomial, put them together by adding or subtracting, and we call that a polynomial. When you have a polynomial, all of those monomials are now called terms. If you have two monomials added or subtracted, it's a binomial. If you have three, we call that a trinomial. Bi implying two, tri implying three, and mono means one. So an example of a monomial from before, maybe -3 x squared y. -3 times x times y. It's one clump of numbers being multiplied together. So binomial is two sets of numbers being added or subtracted. So maybe you have an x squared y plus 5. Maybe you just have x minus 3. So it's the addition or the subtraction of two monomials. Trinomial, maybe you have x squared plus 2x minus 3. So I'm adding and subtracting, adding a 2x, subtracting a 3. Three separate monomials, 1, 2, and 3. So trinomial. Another trinomial is just simply x plus y plus z. It's the addition of three monomials. So that's what a polynomial is. Anything over 3, we just call it a poly for many, polynomial. Degree is a way that we can rate these polynomials. So degree is different than calling it a trinomial. A trinomial is how many terms it has, but the degree is the actual exponents. It has to do with the exponents of the variables. So if you add up the exponents of the variables of the monomial, then you get that monomial's degree. To figure out the degree of a polynomial, the biggest one wins. The greatest degree of any term in the polynomial. So let's take a second to fill out this table, and we'll kind of play the game of, is it a polynomial? If so, what's the degree? And then is it a monomial, binomial, or trinomial? Or it could be more than that. So looking at this first one here, you have a 4y, that's a monomial. It's multiplication of two numbers or variables. 5xz is a monomial, and we're subtracting them. So yes, it's a polynomial. Yes, it's a polynomial. Thought that one showed up, sorry. Okay, because it's the difference of two monomials. The degree, well, let's look at each of them individually. The degree of the first monomial is just 1 because it's y to the first. The degree of the second monomial is 2 because you add up the degree of x to the first and z to the first makes degree 2. So 4y has a degree 1. 5xz has degree 2, but when you're talking about the degree of the polynomial, it's degree 2 because the biggest one wins. And that has two terms, so it's a binomial. So the binomial part is because there's two different terms here, 4y and 5xz. Degree 2 is because of the exponents of the variables, a little bit different. -6.5, is it a polynomial? Yes, it's a number. The degree of this number, it doesn't have a variable. So if it doesn't have a variable, it can't have a degree, so it's 0. The degree of that monomial is 0. There's no exponents of variables to add up there. And this is considered a monomial. It's just a number. So if you're confused on what a monomial is, look in your notes from Chapter 7, the very first section. Part C, now if you look at Part C, that a to the negative third implies that a to the third is in the denominator, and that is not multiplication, that's division, so that's not a monomial at all. And so what we have is not a polynomial. If it's not a monomial, it's not a polynomial. So those same rules of monomials apply to polynomials. So this won't have a degree, and we can't call it anything at this time. Part D, I do notice that this is a monomial. It has degree 3. This has degree 1, and so does this. So because they both have degree 1, that tells me that they're like terms. They should actually be put together. I have 4x's here and another x. That should actually be 5x. So even though it looks like there's 4 terms there, 2 of the terms were the same. So technically they should be put together. And yes, it's a polynomial. It's a trinomial because technically there are 3 unlike terms that can't be combined together. And if I look at the degree of 6x cubed is 3. The degree, right here, 3. 5x to the first, and then this has a degree 0. So when you look at all those degrees, the biggest one wins. The degree of that polynomial is 3. And then just below here, I have a few names, just some terminology, not too important, but something with a 0 degree is called a constant. A constant is like a number. Something that has 0 degree is like negative 15. There's no variable with it. Okay? Anything with an x is linear. Anything that has a degree of x squared is quadratic. Things that are cubed are called cubic. Things to the 4th power are quartic, like 4 quarters or a quart of milk, 4 quarts in a gallon. And then 5, another name for 5 is quintic. Now, we'll study most of those later on. We just did linear. Anything involving linear graphs a line, like x minus 3, or x plus 1, or 2x plus 1. Quadratic, we're going to study later. Okay? They graph something completely different. Anything above 6 or more is just, you say, a 6th power, 6th degree, 7th degree, on and on and on. You just say what degree it is. So not too important, but just a little bit of introductory vocab on that. We got some more vocabulary here. This involves the order in which you write the terms. So standard form is just a way that we write a polynomial. We had forms for linear equations. We had standard form, point-slope form, slope-intercept form. So it's just a way to write the equation. Well, for polynomials, there's a standard form, and it's when you write the polynomial in order from the greatest degree to the least degree. So big to small, highest to lowest. You're allowed to write polynomials in any order. Okay, so if I had x squared plus 2x minus 7, that would be in standard form because it went from the greatest degree 2 down to 1 down to none. But technically, this is the same polynomial. Even though I switched around the 2x and the negative 7, they're the same polynomial. Now, if I asked it to be written in a certain order, it would have to be in a certain order. But if you're just giving an answer and they didn't state what order it had to be in, they're both okay, as long as the sign follows. So if you notice, 7 is negative in the first writing, and so is 7 is negative in the second. So as long as you keep everything consistent, it's fine. Standard form used to be, or sometimes it's called, descending order. When you descend, you go down, like you descend a staircase. So descending order is going down from the highest degree to the lowest, which means ascending order is when it's written in the opposite way, from the lowest to the highest degree. So take some time, make sure you have that all written down and you understand that terminology. Lead coefficient is another term. It has to do with degree. Coefficient is the number in front of the term. And so a coefficient, the lead coefficient, is the number in front of the term with the highest degree. So if you look at the standard form down below, it's written in standard form. It goes from degree 3 down to 2, down to 1, down to none. 7 doesn't have a degree. It's constant. And so the little 3 here is the greatest degree. So this would be considered a cubic. And the lead coefficient then, or the leading coefficient, is 4. Sometimes they call it lead coefficient. Sometimes they call it the leading coefficient. It would be the leader, okay? So just because it's not out in front, if you were to put it in standard form, it is the leader of all the numbers. So a couple little examples here, and then we'll be on our way. We're going to determine if it's a polynomial. If it is, we're going to find the degree and whether it's a monomial, binomial, or trinomial. So the first one, yes, it's a polynomial. And the degree is degree 1 because x has a degree 1 and 4 has degree 0. Well, 4 doesn't have degree 0, but there's no variable with it to have a degree. So it's degree 1. And it is a binomial because there's 2 terms. Number 2, yes, it's a polynomial. Everything's being multiplied together there. This is a monomial, this is a monomial, and this is a monomial. The degree of x squared is 2. The degree of 2xy is also 2. And the degree here is a constant 0. And so the degree of this thing, there's 2 of them that have degree 2, so we just say the bigger one wins. It is a degree 2 polynomial. There's 3 terms, so therefore it's a trinomial. 3 separate terms. Number 3, not a polynomial. And the reason it's not a polynomial is not the 5. If this was divided by 5, it would be fine because that's really 1/5 times it. So the fact that it's not a polynomial is because it's divided by d to the 4th. And 26b to the 5th. Yes, it's a polynomial. It has degree 5, and it's a monomial. Okay? And the last part, write each polynomial in standard form, identify the lead coefficient. So if I look at this first equation here, our polynomial, 9x squared plus 3x to the 6th minus 4x. This is really x to the 1st. That's the biggest degree. We got a 2, a 6, and a 1. So this term goes first. A positive 3x to the 6th goes first, followed by a 9x squared. It's positive as well. And then minus 4x. The leading coefficient is 3. And number 6, I've got a constant. This has degree 0. I've got y, which is 1. I got xy, which is 2. And I got xy squared, which is 3. So that first term is going to be 8xy squared plus 6xy plus 5y plus 12. Everything was positive. I just make sure that the sign follows it. And so my lead coefficient here is 8. And that's pretty much it for today. So I know I didn't put this on your notes. I apologize. I was rushing. I think there's some space on the very front of the page if you want to put the lesson summary. I just have you answer one question here. How do you find the degree of a polynomial? Put it in your own words if you need to. And then just give an example of a trinomial with degree 4. You come up with a trinomial that has degree 4. You can keep it as simple as you need to, or you can try to make it a little bit more complicated. Good luck.